Okay, hopefully you've had time to do those 3 calculations. And I wanted to show you my answers here and see if you got the same answers. Hopefully you did. And if you didn't do them, at least maybe now you'll feel a little more comfortable doing them. Okay, now when you go to pick Q1 and Q2 and P1 and P2, it doesn't really matter which one you pick first. It just matters that if you pick $2 as your, say, your first price, then your first quantity had to be the 11, which is associated with the 2. Now, before I go through this, my answer is 0.30. Anybody get like 3.33? No? Okay, well then let me just talk about this answer. So we get Q1 minus Q2. My first quantity is 11 minus 9 divided by 11 plus 9. And so you've got the difference between those two quantities is 2 divided by their sum is 20. Then the difference between the two prices, well, that's negative 2 divided by their sum, which is 6. At this point, just because of habit, I turn things into a decimal. And, you know, as I mentioned earlier, price elasticity of demand is your answers are in decimal form. So since your answers has to be in a 2 decimal place form, then I convert these fractions to decimals of 3 decimal places. So 2/20, that's 1/10, and that comes out to be 0.100. Oops. And then 2 over 6 is 1/3, or 0.333. And if you take those 2, the numerator and divided by the denominator, you get 0.30. It is negative. We look at it in absolute value, so our answer is 0.30. So what in the world does that mean? Well, first of all, our answer is less than 1. So that means that between $2 and $4, the demand is inelastic for whatever this product is. But you can also learn more information than that. And let me give you a longer interpretation. Between $2 and $4, if price rises 1%, quantity demanded will fall exactly 0.30%. So your answer already is a percent. And again, another way to say that, between $2 and $4, if price falls 1%, quantity demanded will rise exactly 0.30%. Okay, let's go to the next calculation. Next calculation was between $6 and $8. The answer I got was 1.17. Now, some of you might have gotten 1.14, 1.19, 1.16. You know, with elasticity, depending on how you calculate it, and if you use fractions or decimals, or when you convert it to decimals, your answer can be off by a few hundredths. But I would say that as long as you're getting an answer within plus or minus 3/100ths, then you're fine of my answer, 1.17. Everybody get 1.17? Anybody get something like, oh, I don't know, 1 divided by 1.17? Okay, so nobody's saying anything, so I'll just assume you all got 1.17. Okay, I can't skip it. It is so easy when you get comfortable with this formula to just pick up, for example, the two prices, take the difference between them, put it down on a piece of paper, right below it, add them together in your head, put it down, and then look for the two quantities. Now the problem is, if you reverse this formula, percent change in quantity divided by percent change in price, you're going to get the inverse of the correct answer. And it's so easy to do. And for example, the inverse of 0.30 is 3.33. So you get the inverse of the right answer if you pick up the two prices first. And the reason why that's so easy to do is because in most applications and problems and questions, even the columns of data I showed you, price is mentioned first. And that's because price causes quantity to change. So we always typically mention price first. So the second calculation was 7 minus 5 divided by 7 plus 5, which gives us 2 over 12. 6 minus 8 divided by 6 plus 8. The difference between the two prices divided by their sum. And then decimal place, we get like 0.167 divided by 0.143, which gives us 1.17. So what's the interpretation of that? 1.17. Again, I didn't bother with minus signs because I know I'm just looking at my answer in absolute value. So 1.17. Well, that means the demand is elastic. So to give a little more full interpretation of that coefficient, we would say between $6 and $8. A 1% increase in price will cause quantity demanded to fall by 1.17%. Or we could say the opposite. Between $6 and $8, for a 1% decrease in price, quantity demanded will rise 1.17%. Now, the last calculation you did should have been pretty easy because between $6 and $7, the price elasticity of demand is equal to 1 and is unit elastic. So we could say between $6 and $7, for a given percentage change in price, quantity demanded will change by the same percent. Okay, let me return to the resource guide and do one more application, and I'll be done with price elasticity of demand, and I'll leave you to your textbooks. Now, when we first saw price elasticity of demand in the first video, I mentioned that price elasticity of demand is important because it tells us about the relationship between price and total revenue. So what I'm going to ask you to do now is kind of fill in this column or just calculate what the total revenue would be at every given price here. So it's P times Q. 1 times 12 is 12, 2 times 11 is 22, 30, 36, 40, 42, 42, 40. So if you've got that column filled in, you'll notice that total revenue begins at 12. It rises to a maximum of 42 in this area, and then it begins to drop or decline to $40. That's very important to notice. So let's go on with the last kind of piece of price elasticity of demand. Now, there's kind of a short way to determine if the demand is elastic or inelastic or unit elastic, and that's by performing something called the total revenue test. And if the demand is inelastic, we know if price rises, total revenue rises. Of course, the opposite is also true. If price falls, total revenue falls. That's when the demand is inelastic. We can't live without it. Well, elastic is just the opposite. If the price rises and the demand's elastic, total revenue falls. If it's elastic and price falls, total revenue rises. So the last possibility is that the demand could be unit elastic. And in unit elastic, well, it belongs really right in the middle of these two. If price rises or falls, total revenue does not change. And again, the reason why that is because when the price rises or falls, the percentage change in quantity is exactly the same, and it offsets any price change. So they cancel each other out. Now, I asked you to return to that table of data and to go through this little application. Let me just kind of walk you through it. First of all, a way to double check ourselves is the total revenue test. Or, you know, when you calculate, you're in algebra and you have to calculate what the value of x is, and then if you want to prove that you're right, you plug x back into the equation and see if it works. Well, the total revenue test kind of does the same thing. We did the first calculation and we got for between $2 and $4, price elasticity of demand was equal to 0.30, inelastic. So if the demand is inelastic, that means that when the price rises from $2 to $4, the total revenue should also rise. So the question is, did it? When the price rose from $2 to $4, what happened to the total revenue? Well, let me just kind of shift back to that. $2 to $4, well, we got 22 to 36. So yes, when the price rose from $2 to $4, the total revenue rose from 22 to 36, which confirms that the demand is inelastic because price and revenue both moved in the same direction. They both rose. Okay, then let's talk about that relationship between $6 and $8. You did a calculation of elasticity, price elasticity demand between $6 and $8. You should have got an answer like 1.17. So we should know that between $6 and $8 that the demand is elastic, and if the demand is elastic, when price rises from $6 to $8, what should happen to total revenue? Hopefully you realize again that for elastic demand, price and total revenue move in the opposite directions. So for number 2, when the price rose from $6 to $8, total revenue fell from 42 to 40. Total revenue fell from 42 to 40. Again, that confirms that the demand is inelastic. We don't know how inelastic. We only know that when we do the calculation of the coefficient, but we already did that. But this is just a way to prove that, hey, our coefficient's got to be right. And then the third one is when the price rose from $6 to $7, total revenue. Well, at $6 and $7, the total revenue remained the same at $42. And that confirms that the price elasticity of demand between $6 and $7 must be unit elastic. Okay, I'm going to stop right there, and hopefully that overview of elasticity will get you a good start in that particular chapter, and I hope that you find it not quite as intimidating as it might seem at first blush. Anyway, good luck on that chapter.